Hi there, let us begin this tutorial on data models and ER diagram. Fine. Now, just at the beginning, I want to say that I have divided this ER diagram part into two parts. It is a kind of huge, okay, so I cannot finish it in one tutorial. So it's good for making it into two parts and finish it off easily. Now, before starting in the ER diagram, we need to understand what is a data model and what is database model. So it's very important. Now, what is a data model? A data model is a model actually, which is a collection of tools, okay, that can be used to describe the data and the relationships. So it is, I will say that it is a kind of mother of all the database model. Fine. Now you can ask me, so what is the use of this data model in database management system? So data models, data models is the way we arrange a data. Fine. You take a data, you link it somewhere like this, and if you arrange the data in a square format, then you can say, I'm just giving an example, okay. So suppose if you're taking the data and arranging the data in a square format, then we will say that yes, the data has been arranged in a square format, so let's name it as the square model. And if you take a triangle and if you arrange it like this in a triangular format, you arrange the data in a triangular format, then you can say it's a T model. So it's triangular model. Fine. The same case is happening over here. Now what is the difference is that if you take, suppose in case of say you take the data and you arrange it in a specific way. Suppose for object oriented concept, I've already told you in the part 3, okay. So you take it, this is again divided into several other parts, and this is again divided into several other parts. It will go on object based like this, dividing. And suppose for the network concept, if you take a table like this, the tables are linked to form a network amongst themselves. Suppose with this and this with this and this with this, you take another, like you can just connect it with this and connect this and connect with this. That means what? That means all the data is always same, okay. But what is changing is the way we are linking the data with one another. Fine. So this is the function of the data model. So you take the data, fine, and you arrange it in a specific format, specific way, and we will get a specific model for that. So for this we get a network database model. For this we get a object oriented database model. That means what? That means I can say that data that means models are the mother is the mother of all the. So this, if you divide the if you take the data and arrange it in a specific way, then we will get suppose network model. And if you take the data and arrange it in a object oriented way, we will get object oriented model. And if you take the data and arrange it in a relational, suppose relational database table, then we will get a relational database uh, model. Now the thing is that, what is the difference is nothing. Difference is that the data models is the highest, is the bigger concept. When you arrange the data and arrange it in a particular way, a specific way, a specific manner, then we'll get the several individual database models. Fine. So database models, this is the connection, this is the ultimate connection between the data models and database models. So data model, we take the data, we arrange it in a particular format, and we get database model, okay. That is it. Now the second thing, ER diagram. Now I will explain this, what is the really the relation between this data model and this ER diagram over here, right? So you can ask me that. So for that, I will tell you that what is a, first of all, what is a data model? Data model, I have told you, it is a collection of tools that can be used to describe our data and their relationships. Fine. So ER diagram is actually a kind of data model, okay. ER diagram is a kind of data model, and it can be used to represent the relational database management system, RDBMS. Okay, RDBMS, beautifully. Okay, that's why we are dealing with this ER diagram right now. Now, according to the criteria, I am dividing the whole ER diagram thing into three major concepts. The first is the components, second is the relationship, and third is the extended features. Components means what are the tools that are used, basic tools that are used for the in the ER diagram. Second is the what are the relationship methods and what are the relationship tools that are used, and the second and third and last is the important thing. These are the high concepts. Okay, so once we master these first two ways of using this ER diagram, we can easily go to the extended concept and find it out. Okay, now this is the relation between data models and ER diagram. Now let me just go into detail and just explain to you that suppose if I provide you two tables, okay, table number 1 and table number 2, and if there are if these are the so these are the two, and forget about all this database and all these things right now. And if I ask you how will you link with these two tables, so what are the possible ways of linking it? First of all, there should be tables. Okay, so without any tables I cannot link it. Second thing is that there should be at least a single attribute, single column in that table, otherwise there is no use of such a table. Otherwise the existence of such a table is null. Okay, so first of all, over here in a diagram, the first concept is always the entity. So first concept is always the entity. The first in the AR diagram component, the first concept is the entity. So whatever we take, whatever in our database we meet, it is an entity. An entity is just an object or individual objects about the data that must be captured. Fine. So over here I'm providing you, suppose if I give you an example, that will be very much important, right? If I give you a practical example, it will be very good. So suppose okay, let's see. If I have two family with you, okay, so family 1 F1, and this is family 2. Great. Now the thing is that entity over here is generally represented by boxes, so rectangle. Okay, rectangles. So suppose, so family over here is there given. Now the family contains three members. The first member is suppose mother, both family. Second member is father, both family, and the third member is suppose one over here is son, and over here is daughter. The thing is that suppose if you consider this, that the son and the daughter, they marries. Okay, they marries over here. That means what? The family is an entity over here and is represented by rectangle. It is also family 2 is also an entity. So according to the definition of entity, it is an object about which the data is needed to be collected. Fine. So what are the data that we are collecting for a family 1? Only three data that we are collecting, that is the family consists of a mother, father and son, whereas in family 2 we are collecting about the mother, father and daughter. And when they are married, fine, then a relationship between the two families are created. And what is the name of the relationship? It is the name is marriage, suppose MA. Okay, marriage. So this is how you explain the thing. Well, now attribute. Now the next thing that I want to introduce is attribute. You understand what is an attribute? Attribute is this data that we are gathering, okay, regarding any entity is actually called attribute, nothing more than that. Okay, this is called attribute. So information regarding any entity is captured in the form of attributes. right? Now there are several categories of attributes, okay, so according to which we can just classify the attributes. The first of all, so here it is the components. This is the second part. The first a was the entity and b is the attribute. So now let me give you an example. Okay, so what is an attribute? Attribute is just the property of an entity. So if I consider entity, suppose let me give myself as the entity, then it has several attributes. Now I have it is classified. Several attributes are classified according to its data provided to it. Fine. So the first type of attribute is called simple attribute. Simple attribute. What is a simple attribute? A simple attribute is that attribute that cannot be further divided into or subdivided into any other attributes. For example, so if I say uh, my name, okay, and then my name is falls under this simple attribute category, okay, or my, you can say whatever, my address. So name, address, you cannot divide these things, okay. There is no need for divisions. You can of course divide every data into a very small component into alphabets, okay, but there is no need actually. You can divide my name into my first name and second name, but there's no need, okay. So I will consider this to be the simple attribute. The next attribute that comes is just the opposite of the simple attribute. It's called compound attribute or composite attribute, okay. What is a composite attribute? Composite attribute means the attribute that is made up of uh, other attributes. Suppose you can understand if I give an example. Suppose it's my date of birth, DOB, okay. So date of birth, consists of many things. Suppose if I divide it into suppose day and month and year, and this is the composite attribute. What is composite attribute then? The attribute that is made up of several other attributes, simple attributes, is called a composite attribute. What is the third category? Third category is the single valued attribute. Single valued attribute. Now what is single value? That means that the value provided over here is single, okay. Suppose my driving license number, DL DLN, okay. So I cannot possess more than one driving license, suppose, okay. So it is not possible for so the driving license, only one thing is provided, and no more than one driving license is not permitted. So this is single valued. Only one valued is admissible. This is allowed. And just the opposite of the single valued attribute is the multi-valued attribute, MVA, okay. Now what is multi-valued? Suppose uh, my mobile number. So it's very natural these days to have at least two mobile numbers, contact numbers, okay. So you can have this mobile number. So you can have one or more mobile numbers. So this is mobile numbers, yeah, mobile number, a contact number, whatever. So this is the multi-valued attribute. This is the opposite of the single valued attribute. And the last of all is the derived attribute. Derived attribute means it is, you can say the age, okay, age, age, great. Now how it is derived? Derived means you can actually derive this age from my date of birth. You can calculate the date of birth, and that's how you can calculate the age of mine. So it is derived. That's why you are provided with the data of the suppose my date of birth, and from there you are manipulating the data to get my age. So this is called derived attribute. Now the thing is that there is a special way of representing all these attributes, okay. So I will just give you a hint that suppose I've given this diagram to make you understand, okay, but now I'm just rubbing it so I can tell you. So the thing is that how this simple attribute is generally represented using normal ellipse, okay, but uh, uh, this multi-valued attribute multi-valued attribute is generally represented using double ellipse. So mobile number is the multi-valued attribute over here, so I am going to represent it like this, double ellipses, okay. And whereas the derived attribute, suppose age is a derived attribute, it is generally represented by dashed ellipse, okay. So I'm trying to make it a dashed, okay. So this is how the dashed ellipse looks like, okay. So it is simple, I think so, and I hope you have understood this one. So it's very simple. First of all, that ER diagram is a data model. Data model is nothing but a set of tools that is used to represent a data, okay. Now what are the set of tools provided to ER diagram? The first set of tool is the entity, the second is the ellipses or the attributes. Now attributes has some several parts, five classifications according to which we have done, okay. So we'll be doing with this we'll be facing some of the uh, examples in the later part, so you will have a clear idea regarding ER diagram, okay. Okay, so there are some more components that I want to mention over here. The you will be facing you will be I will be giving this to you in the later part, okay. But I think so it is important to know that the line, a single straight line, is generally used for, suppose, like this. Suppose these are the two rectangles and there is a line between them. This means that this line is actually representing the link, okay. What is that link between entities, okay, link. And if I want to mention any relationship between two entities, suppose in the previous example of the families, so a family is generally, so it's kind of diamond shape, and family 1 and family 2, so f1 and f2, f1 and f2, okay. So this is the line, this is the line that is a link between two entities, and this diamond shape is generally representing the relationship, okay. Relation, relationship between two entities, okay. So here the family 1 and family 2 shares the relationship of marriage over here, so I will write M. So this two things is slightly important for the later part of the tutorial, okay. I'm ending this first tutorial on ER diagram and data models. I will be very much honored if you just subscribe to my channel, okay. And please visit my site. Thank you very much. Stay tuned for the next updates I will be giving. Thank you very much again.